There you go. Now you can hear me. I'm glad you got your computer working again. Hello. Yeah. You get to this. And straight. Really close. Hello. So I'm not using the swivel with the iPad. So this is just my laptop up at the front of the room.
Okay.
Because that way I can hear y'all and y'all can hear me. And then also I'm going to set up the virtual whiteboard and work some problems from this section. This is 2.5 still. And we're going to be working on the organizer handout. So if you have that printed out, you can get that out and work on it.
Okay.
From that? No, from that, yeah. You're almost done, right? May I also work some of the problems? Yes. I'm going to use this over here. I'm going to put up the whiteboard and work some of them also. Let's see. So where are you at, Brian, on your work? Are you in the middle of the problems, or have you?
I'm kind of in the middle of the problems, yeah.
Yeah. Okay. I'm going to do a few of them on the whiteboard on the screen. If I can get it figured out here. Also, I want to.
59, 91, and 97.
Okay. Share if you want. Put your stuff on. And there's Eddie. Okay, a little late. Hey, Eddie, can you hear me?
Yes, ma'am.
Alrighty. We're just still working on section 2.5 problems and the organizer handout, which hopefully you printed out. 17. Anna, would you mind closing the door? Appreciate it.
I haven't printed the organizer yet, mate. I need to
do that real quick.
Okay, that's fine.
Thank you.
Mrs. Fisher,
Yeah.
when we're done, do you want to check our like Yeah. It is.
Bless you. Mm, 15 times 3, 9 times 5. Wait a minute. Damn. Okay, so this one.
Everything left. In there.
Yeah.
You're good. And yep, good job, ladies.
Is between 1 and 2.
I hate myself. Why do I say anything?
Okay, let's see. Okay, let me go back up here. Okay, so Candace, that's number 17. Does that make sense?
No, ma'am.
Was that a no?
No, ma'am, it does not.
Okay. Can you put like a little star or something or mark on it where you're not sure? They, on 17, they're,
I mean,
well, looking at the instructions, they're saying use the rational root test to list the possible rational zeros. Okay, so the rational root, the rational zero test is where they mention, you can flip back to, let's see, it's page 155. And they put P over Q, where the constant term over here is P, and then the leading coefficient here is Q. And so they say that if you put all the factors of P, any combination of the factors of P over the factors of 2 or Q, which I listed them all up here, the 45, 15, 9, 5, 3, and 1, those are all factors of 45. So any of those numbers divided by any of the factors of 2, which are plus or minus 2, plus or minus 1, any of those numbers could be possibly a rational zero. In other words, where it crosses the x-axis. Since it's a 4th degree polynomial, this 4 up here in the n equals 4 here, that means it could have up to 4 roots, and it does have 4 roots. You see those where I circled in yellow. And what the rational zero test says is that those numbers where it crosses the x-axis has to be one of these numbers, either 45 divided by 2 or 45 divided by 1, either positive or negative, and 15 divided by 2 or 15 divided by 1, either positive or negative, and then 9 divided by 2 or 9 divided by 1, either negative or positive, and so on. And when you look at it, because it says the directions say to verify that the zeros shown on the graph are contained on the list. So all these factors over these factors, that's basically the list. You don't have to write them all out. I mean, if you did write them all out, it would take forever. You'd have to say 45, that messed up, hang on. And you'd have to say negative 45, and then you'd have to say 45 halves, which is 22.5, or negative 22.5, and so on. You'd have to do that for each one of these. But if you just list this fraction right here like that, that's good enough as the list. And so if you notice, they show that the roots look like they're -1, 1.5, 3, and 5. And if you go over here, you can see I have a 5 and a 3 and a 1 divided by 1. Yeah, that would be what I'm talking about, where you put the stars, is this 1 over this one, but it's positive or negative, so that you can do, either one of these can be negative. And so a 1 over a 1, that's on the list. And then 3, you have a 3, and it can be over a 1. So that's on the list. And then 5 here is on the list also. And then the other one over here, the 3.2, this one, that was this one right here on the graph. Draw a line for that one. All I could really tell, it was in between 1 and 2, but when I looked at in the book, it was between 1 and 2. And so when I look at these fractions over here, like 5 over 2 is 2.5. That's bigger than 2. And 1 over 2 is 1/2. So it'd have to be the 3 over 2. The 3 over 2 is the only combination that would give me a number that's between 1 and 2, the 3 over the 2. And that gives me a 1.5. So it's also on the list. 3 over 2 is on the list. But you have a 3 here in the numerator and a 2 down in the denominator. I don't know if that helped any. Do you understand how you get the list?
Yes, ma'am.
Using the constant term and the leading coefficient. Yeah.
Yes, ma'am.
Yeah. Let's see, what was the other one? I think you had. So if you want to, you can save that screen, because I'm going to be clearing it off in a minute. Do you have any other questions on that particular problem? I'll take that as a no. And you wanted to see number 19. So I'm going to clear this. Are you ready for me to clear it? Edwards entered the waiting room. Okay.
Yes, ma'am.
Okay. I think I'll save it first and then clear it. Okay. Did y'all get the other ones then?
Yes.
You got them right?
Well,
That's right. But you got the, you know, all positive or alternating, so.
I don't have the
All positive, alternating.
hand. I do have paper too.
Yeah, those look good.
When did
I don't know how they would
the
vary.
hand out?
I don't think they just wanted to mess with it. Okay, so 19, find the rational zeros. Okay, this will probably be more instructive, Candace, when I work this one, so I can do it clearly. 3 minus 7x minus 6. Okay, so I'm gonna go color. There's 6, there's 1. So now, in this particular case, since 6 is such a small number, I could actually list out all those rational roots. I could either have 6 or negative 6, and you only have a 1 down here, so that helps. It could be positive 3 or 3, 2 or positive 3 or negative 3, positive 2 or negative 2, positive 1 or negative 1. Because all of these, if you divide them by positive or negative, you would get these values. So these are all the possibilities. Okay, so it kind of narrows it down a little bit. And then what we can do is just try some of these out using synthetic division. So I'm going to put something here and put a 1, and then I had to put a 0 for the x squared term, and then a negative 7 for the x term, and then a negative 6. So we're going to try one of these out. Let's see. I'm going to try a positive 3. I'm going to put a 3 over here. And that's just random. I just randomly picked a positive 3. You can pick any one you want. So I'm going to put a 1 down here. 3 times 1 is 3. Add those up, I get 3. 3 times 3 is 9. 9 minus 7 is 2. Looky there. I'm so proud of myself. 3 times 2 is 6. And then I get a 0 here. So yay, it worked. In other words, 3 is actually a rational 0. So what that means is one of the factors is x minus 3. And the other factor I get from these numbers, which would mean it would be 1x squared plus 3x plus 2. Okay, so these numbers are where I get this from. Does that make sense so far? I found all the possibles and I picked one out of those. And if it hadn't worked, I'd just pick another one and I'd keep trying them. Or I could even put it on my calculator and look and see which of these numbers that looks like it's going to go through. But I was lucky because the first one I tried 3 gave me a 0 here, which means 3 is a 0, which means x minus 3 is a factor. And I want to get the other 0. So what I can do, instead of just sticking in these other numbers and just trial and error, I'm going to take this. Let me go and change the color here to blue. I'm going to take this, what was left over, and see if I can factor it. So x squared, so I put an x here and an x here, and then I want 2 values that'll multiply to give me 2. So 2 and 1, and they add also to give me 3. So there you go. And so these are all the factors. They're called linear factors because they're x to the 1 power. And so that means that the zeros then are x equals 3, x equals -2, and x equals -1. So that's what they wanted us to find. And so I used the possible rational zero test to narrow down some things for me to try. And then I used synthetic division to verify one of them. And then once I divided by that root, I used what was left over to factor, because it was just a quadratic that I could factor this way. Let's see. Yes.
I don't think I got a handout.
Why not?
I was probably. Okay.
Let me go and number the order I did these in. And get a color black. So here's the first step. Second step. Third step, picking 3 here and doing the synthetic division. And then the fourth step was to factor this quadratic. And then you can just finally get all that and write the zeros. Does that help on number 19?
Yes, ma'am.
Okay, you want to save that and I'll let me see what the next one is. $25. Okay, so I'm going to save this one and I'm going to clear all the drawings. And I'm going to do 25 and let's close that. Okay. Okay, on these synthetic divisions, you got to be sure you put in placeholders because there was no X term. Double check, right? So I have to put it at 0 there and then a -1. 1 times 2 is 2. 2 plus 3 is 5. 1 times 5 is 5. And that. And -5. It's not 0, so 1 is not a, and that actually, let me go ahead and put a 4 here. So 0. Okay, so I'm going to cross off 1 over here. And another thing, when you see that all these are positive numbers, then that shows, that's what you call the upper bound test. If I try a positive number and everything I get are positives when I do the synthetic division, that means that there aren't any numbers. That means that 1 is a upper bound. In other words, there's not going to be a root that's any higher than 1, which we already knew that because that was the biggest one of our choices up here. But I just wanted to say that because that it illustrates that upper bound rule. So let's try -1. So I'm going to go to another color and try to fit it in over here. I really don't want to do the fractions if I don't have to. So let's try -1. -1. -1 times -1 is +1, and that does give me a 0. Yay! So -1 is a 0. Okay, then the next step is I wish I could scroll this up, is I can take all of this and turn it into the quadratic that's left. So that's 2x squared plus x, or 1x minus 1. And I can factor that into maybe something. Maybe a 2x and a 1x. Let's see. -1 plus 2. Would that work? Because that would give us 2x minus 2x. That would not work. Oh, okay. So let me erase things. This will be a 1. Okay, so I'm just trialing and error these. 2x minus 1 and x plus 1. That would give me 2x minus x, give me a 1x. Okay, yeah. And so when I factored that trinomial, the quadratic trinomial, I get 2x minus 1 and x plus 1. So now I'm going to set those equal to 0 to find out what my roots are. So 2x minus 1 equals 0. So 2x equals 1. So x equals 1/2. So there's a 0. Then I'd say x plus 1 equals 0. So x equals -1, which I already knew. That means it's 1 twice. There's a -1 here in my original -1. And so that's what we call a repeated 0. And so -1 is a 0 and 1/2, positive 1/2 is a 0. So your answer would be -1 and comma 1/2. Those are your zeros. X equals. And hopefully that's what they got in the back. I'm going to double check it though. It was 25. One have to make it over now. How are y'all doing on the things? Finding them all? I think this one, yeah. We spent a long time on this next one section because it covers a lot. Like 4 pages, right? If you see another one you want me to work, or if Brian or Eddie want me to work one, or James, I can do that also. Let's see what. Now I can see you. Hey, Eddie, are you there?
Yes,
Unmute.
ma'am.
Yeah, so what if you used a phone? Then I would be able to see you, right?
Oh, okay. Let me do that
Let's
real
give
quick.
it a- Huh?
Or buy a $20 webcam.
Yeah. Do those just like plug into one of the USB things?
USB.
Yeah. Yeah, because not being seen is not acceptable. Look at Brian not wearing any dress code. Just kidding. Don't worry, I'm not going to turn you in. And we never know about Candace. We only see the top of her head, too. The sophomores were bragging about how they wore chapel uniform, even though they were virtual yesterday. But then they admitted today it was just from the top up, the waist up. Okay, so Brian or Eddie, do y'all have questions at this point?
No, ma'am.
No, I'm doing pretty good.
You're doing pretty good. Am I missing James? I never saw James.
Yes, ma'am.
Oh, well, okay. So I don't know if I took roll or not. I think I did. I'm gonna go check. Oh, I didn't. Okay, good. Let me do that then. Pre-cal. Mr. Smith, did you see that you can actually pick virtual on this?
Mhm.
That's cool. Okay, so Brian is virtual. Eddie is virtual. Candace is virtual. James is, I guess, absent. Okay. Okay, so Candace, did you need to see the rest? You want me to share that screen again, or did you get it all?
I got everything saved so I can look at it when I need to.
Okay, do you have another problem you'd like to see on the board?
Not at the moment, thank you.
Okay. I'll be back. Let me know if you need it. You can, oh, y'all are showing. Okay, I'm gonna turn y'all off so you're not looking at everybody. Just on the white board. There we go. Okay, but just holler if you need something. I'll come up and help you out. How's it going, Eddie? You working on your phone?
Yes, ma'am.
Ooh, you're
there it
waiting. Okay, let me try it.
There we go.
Let's see, admit. Dun, 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 dun. Come on. Yay. Connecting to audio.
Oh, wait. There we go.
Yay. See, look, everybody, there's Eddie, and he's actually in uniform. Oh, let me do this and y'all can see them. Woo. It shows everybody. Okay. So, Eddie, you got any questions at this point on any of the problems?
No, ma'am.
Okay. Well, if any of y'all do, just unmute and say, and call me and I'll come help you.
Yes, ma'am. Thank you.
Erasing the virtual whiteboard is so much easier than erasing the real ones. People didn't use.
Yeah, I used mine today
You were leaving it for you.
on Zoom. I was like, I need to save this.
The virtual one or the?
Yeah.
Yeah.
You should look at the green check the time.
Oh, yeah, no, that's right. I realize that. I was giving you a hard time. I found out that if I go and get some speakers and hook it up to the swivel, then I'll be able to hear students when I'm using the swivel. But if I don't, the only way I can hear them is using just my computer. And so I'm gonna go to Best Buy and pick up that. I ordered a little adapter, so it'll come in on Thursday. Then I'll have the whole system. Hopefully working good. I'll be able to use my whiteboard and it'll be able to follow me around and I can go in and look at me and it'll be like a normal class.
Stuff is get that 5.1 surround sound.
No,
Really hear it.
$25.
That's
That's right. It seems like the whole could use the speakers on that. And you can use earphones to hear the students by plugging them in there. But I can't use earphones that have hearing aids. I might pick up that virtual, Bluetooth, that one you get to.
So you have your Bluetooth hearing aid.
Yeah.
My dad does that when he actually, he doesn't. He'd like have his phone down here and just be talking. Who are you talking to? I'm on the phone. How? And then you see him in his ears.
Yeah, because the people can hear me through the speaker on the hearing aid. And my phone too, I can watch right there. But I get phone calls through there, or it will alert me, or I can answer here and then talk. So the teacher faculty type of thing, and I'm over there looking like I'm paying attention. I really am, but I could be listening to music. Yes, we do. It's on the announcements. Check it, let me know.
Let's see anything on the calendar. We have it next Tuesday.
Next Tuesday, okay, well, good. Just
Mrs. Belcher,
yes.
I need help on the success organizer on the second page where it says write the polynomial function fx equals x to the fourth plus 5x squared minus 36.
Okay, hang on. Oh. Okay, that's the third page. Oh, well,
Oh, yeah. That's
Yeah. The right polynomial as a product of linear factors.
this one.
Yeah. Okay, let me go to a shared screen and put it up here. There's a couple ways you can approach this one. Okay. This is actually page 43, it says up at the top, right? And section 2.5 handout. Okay, so you got f of x. Can you see that okay? I mean, we can turn the light out if we need to. Okay. Doesn't seem as clear as it could be. Okay, so that's going to be equal to x to the 4 plus 5x squared minus 36. Okay, so, well, I wrote poo, just kidding. If possible, zeros would be factors of 36. Oh my goodness. Okay, so that would be plus or minus 36, plus or minus 18, right? Yeah. Or minus 12, plus or minus 6, plus or minus 2 and 3. I'll say 3 and then 2. Any of those numbers over plus or minus 1. And that's a lot to check out. So, yeah, yes? 9 and 4, thank you. Making it even harder. Okay, so go back. So, so what we're going to do instead is we're going to check calculator to narrow it down. Okay, so hang on, let me type it in to my calculator. X raised to the 4th plus 5x squared. It is squared, right? Yeah, minus 36. And it looks like on my just my regular negative 10 to 10 window on my calculator, it has something coming down and then disappearing and then coming back up like that. So probably it comes down somewhere down here and it goes back up. But these are what we're interested in, these points right here. And they look like -2 and +2. Okay, is it time to go? Yes, it is. Okay, so since it looks like +2 and -2, try those out. Synthetically divide this by +2 and then by -2, and then you'll be left with a quadratic that you can factor further. I'm gonna go ahead and stay here and work on it, but y'all can go if you want to. You're dismissed. Okay, so.
Thank you.
So we got a 1 and a 0 for the cube term and a 5, and a 0 for the x term, and then a -30. Okay, so those of you on virtual, y'all can leave the meeting if you want to also. I'm just gonna go ahead and finish this so I can save it. 2, 9, and 18, 18. 0. Okay, and then I'm gonna take this and synthetically divide the -2.
It looks like a dream. It looks like a dream.
No. Here.
Here's it, the trainer from this
This last leftover. You're welcome.
hit yourself in the face with your reminder. Yeah. Bust your lip open. Yeah. Yeah. Like your pencil.
Yep, they work.
Yeah, so what you have left is 1x squared plus 9, which gives you, hang on, let me see what they-
Maybe I should leave it here. Like, put it in the-
okay, so, let's see. Erase here, erase. I'm gonna set that last factor equal to 0. Because of the negative, the square root of a negative, oh, it's not 9 here. Okay, hang on. There we go. So those are the other two zeros. So you got -2, +2, and plus or minus 3i. And it asks, explain why a graph cannot be used to locate complex zeros. Graph only shows, I don't know what they want for that. The graph only shows real zeros. So it shows those two, but not that one, not the plus or minus I. Okay, so I'm gonna. So try to finish up the worksheets, anybody that's left. I don't know if anybody is. See you later,
Yes, ma'am.
Betty. Okay, yeah, try to finish what's left and I'll answer any questions that you may still have before we get into tomorrow's stuff. Do you
Yes,
know when
ma'am.
you'll be coming back? But
Thursday.
Thursday, okay. And Candace, you can also send me any problems that you have questions about. Sound good?
Yes, ma'am.
Okay, well, I'll talk to you
It
later
does.
then.
Thank.
Thank you,
You're
Mrs.
welcome.
Belcher.
Yes, ma'am. Bye.
Bye-bye.